Hello, and welcome to Notes 2020. Thank you for joining us today. My name is Bruno Gonçalves, and I'm the founder and senior data scientist at Data for Science. Data for Science is your resource to learn to take control of your data. We specialize in online webinars, in-person workshops, and corporate trainings, ranging in a variety of data science topics from networks and graphs to the basics of NLP, pandas, and even the finer points of causal analysis. We also run a weekly newsletter, the Sunday Briefing, that covers all the latest developments, news, tutorials, and blog posts about machine learning, data science, and artificial intelligence. You should sign up at Data for Science, that's DATA, the number 4, sci.com/newsletter. Now I'd like to introduce you to our speaker, David Meza. David Meza serves as a senior data scientist at the NASA's Office of Human Capital in DC. Today, he will speak to us about developing a knowledge graph of your knowledge, skills, abilities, tasks, and training. David previously served as a chief knowledge architect at NASA's Johnson Space Center, JSC, and in his desire to improve IT processes and systems, led him to earn a master's degree in project management and Six Sigma, in addition to becoming a NASA-certified Learn Six Sigma Master Black Belt. Mr. Meza is also conducting some research on people analytics, automatic classification, algorithms, domain-specific search interfaces, topic modeling, data-driven visualization, and the graph neural networks. He holds a master's in engineering management from the University of Houston at Clear Lake, where he is currently pursuing a doctorate in education. Thank you for joining us, and please join me in welcoming David.
Thank you. I appreciate the introduction and pleasure to be here. Appreciate everybody showing up for this opportunity to give me to talk about knowledge graphs and how we utilize them at NASA and how I'm able to take a look at a brand new area of people analytics and how we're utilizing knowledge graphs to try to gain some insights as to our skills, our abilities, our tasks, and our trainings, and how we can utilize knowledge graphs, and in particular Neo4j, to be able to answer particular questions about our workforce. So first of all, I'd like to start off a little bit about how do we create knowledge graphs? What is a knowledge graph? How do you utilize it? What are the tools that you're going to need to be able to create this knowledge graph? One of the first things I always tell my folks when I work with them is you have to understand your domain. That's critical in any kind of data science problem. And when you're trying to get some answers from particular types of domain sets. If you don't understand your domain, you're not going to understand the questions, much less be able to really come up with a viable answer that's going to help your end users. Once you understand the domain, then you need to start asking questions. Those questions are related back to your business problems, the things that you want to look at to try to help your organization succeed in its mission and be successful competitively, as well as do as best as it can for its workforce. Once you've done that, then you start looking at defining your model. And in here, we're talking about a graph model and how it connects. The beauty about knowledge graphs, when I think about knowledge graphs, is that you can start off with one particular model and then add to it. Unlike a relational database, or your traditional relational databases, where you kind of have to understand your schema, your data model beforehand, and really have that set up when you start adding your data and normalizing your data and making sure you have your foreign keys and your primary keys successfully done there. Within a graph model such as this, you can start off with one basic understanding of a particular concept, and then add to that concept and add in additional knowledge as you move forward, making those connections graphically through a graph database. And I'll show a little of those examples as I move forward. Once you've been able to define your model, you guys then have to start looking at the analysis. What are you going to do to this graph? What are you going to do to the information within the graph? How are you going to utilize it? We're going to take a few little look at how we utilize natural language processing to find the information we have within our employee skill set. And what do I use to be able to do this for this particular problem anyway? The link there to the KSATT repo within my GitHub account will provide you with a Python script that'll actually load some of this information onto you and how to kind of put that into a graph database fairly quickly, and then you can start working on things. We use Jacquard similarity, some from the graph data science framework, to pull out some answers. We also incorporated some Python GenSim algorithms using Doc2Vec, doing some entity extraction, and we're currently evaluating different things we can do in neural nets, graph neural nets, as well as we're evaluating BERT, recurrent neural networks, and utilizing the SPACY libraries in order to do some of that natural language processing. All right, so let's dive in a little bit. As I talked earlier, understanding your domain is critical. So when I first joined the People Analytics Group at NASA about 6 months ago from my prior position as Chief Knowledge Architect out at Johnson Space Center, I really had to dive in to understand what People Analytics is, how we're going to utilize it, and what we have to gain from that. One of the things that first popped up, especially under these times we're having right now with COVID, is we're getting issues with the workforce really needs to have new skills in their work to be able to deal not only with how you work, but getting that work taken care of and done during the trying times we have. So understanding that skill set was very important. So I had to dive into to figure out what is the skill set made of, how do you interpret all of that? What are the different features across not only an occupation, but an employee and other factors that the employee may have, so we can extract those types of skills and or elements, as I'll start calling them, across both either an occupation or an employee. And those elements can be made up of various things such as basic skills, cross-functional skills, abilities, tasks, certifications, education, requirements. All of those things make up both an occupation and things that an employee must meet in order to fit a certain occupation or work role. So again, as we were doing some more research within that field, Gartner had a lot of good surveys. The emergence of new tasks and new responsibilities for employees was really high up among the list of a lot of CEOs and chief human capital officers. You can see in that growth. So that really started to dive into the problem we were having to try to understand what we were trying to do. In particular, as NASA is trying to get back to the moon and onto Mars, we've got to not only regenerate the skills we did just to get to the moon before, but look at new skills and new programs and projects we have to develop in order to get onto Mars, and some of the new technologies that we have to try to incorporate to do that. So we really needed to have a good understanding of our workforce to be able to do that. And the last thing I want to mention here about as far as the skills is building critical skill sets and competencies was first and foremost on the minds of many HR groups and trying to figure out how they're going to do that. So as you build your knowledge graph just about an occupation and the skill sets, how are you going to build those critical skill sets? How are you going to identify those skills? What are adjacent skills necessary for that? What training may be required to get those skills? Those are all questions and things you may want to look at as you're starting to develop your knowledge graphs around occupations and skill sets. So as I talk a little bit more about the questions, we started brainstorming, what is it that we want to know about our workforce? Initially, basically, let's just map it. Where are skills located across the United States? NASA has 10 different centers and another 7 facilities with over 60, 70,000 people spread out across the United States. And we have this wide skill set. So where are our skills located at those centers, within those programs and projects, within certain locations? Those are questions we can start to pull out of this information as we develop this knowledge graph as we're thinking through it. We can also identify adjacent skills. If you know Cypher, maybe you also know SQL or vice versa, or should you be learning one or the other? If you know Python, do you know R? Do you know Fortran? Things like that, so that we can try to figure out what adjacent skills are there, which then starts to, as you progress from that, you can start thinking about, here's the skill I have, other people also have. Like if I have Python, other people have R that also have Python, maybe I need to start learning that. What are the training tools I need to be able to learn R in order to enhance my skills and to make myself more valuable for my organization? And one of the last questions I'll feature here today is, I want to change careers. What should I learn? What are my options? What are my opportunities? What can I do if I wanted to go from a management position maybe into more of a technical position? And I'll show a simple query that I did to try to get some of that information out of our knowledge graph. Well, let's start off. Now that I've identified, I've learned my domain, I understand my information that I'm trying to gather, and I have to look at my model. And I took a look at this information technology competency model that I was able to extract from the Department of Labor, and it provides a lot of good information as to what I'm going to need within my database and things that I'm going to need to capture. I need management competencies. I need specific requirements, all the way down the pyramid, down to industry sector specific, industry wide, workforce competencies, academic competence, and so forth. All of that information is going to be brought into your database, into your knowledge base, on your knowledge graph, in order to be able to pull this information out, write the queries, and really extract as much information you can about your workforce or the occupation you're looking for. But if you look about it, that's a lot of information. Where am I going to get this? What am I going to do? It's one of the benefits of open source data that's out there, and in this particular case, from a graph, from a data occupation data perspective, is there are a lot of information out there about these things already been done by government agencies. The Department of Labor has an ONET database that has a little over 1,000 different occupations with detailed skills, and that's already preset within a in their framework, with you follow in their taxonomy within their own structured database, and you can pull that out as CSVs, Excel files, or other relational databases, MySQL or SQL type of structures, and utilize that. So I was able to extract from ONET that information and put it into a graph database. There are other sets of information you can get from OPM, as well as ESCO, the European Skills, Competencies, Qualifications, and Occupations, that also has a set of skills and competencies listed for each occupation. Makes it very useful as a base for how I'm going to start identifying. So from a knowledge graph perspective, this is one piece of knowledge that I'm going to use as my base to build upon in order to start putting these disparate connections together in order to be able to grab more information and understand what I need across my skill set or my workforce a little easier. So if I dive down a little bit into the ONET itself, again, you've got a little over 1,000 occupations, and they're broken down into broad, major, and minor groups. You've got different data levels. All of that is just a wealth of information we can utilize to put into our graph database in order to start making the connections. But it is in a regular structured or relational database model that we're going to have to pull out. And again, I'll show the script in a little bit of how we do all of that and able to put that into a graph database. But once you've gotten all that information and you've looked at it, you kind of understand your domain, you've got a starting base, then you got to start building your model. And here's a simple model that I utilized when I started looking at this. So on the far left, you've got your ONET database, or your ESCO, or your NIST information of all these different occupations. Out of that, I'm able to start bringing up all the different elements that make up an occupation. In this case, we've got things such as tools used, work activities, knowledge, technology skills, interest, and so forth. All of those can be found in an occupation, which is right there in kind of in the center. Well, now that I have that, I can start doing a little bit more information in crosswalking. I was able to crosswalk the ONET occupation with our internal OPM series guidelines, government guidelines for occupations, making that connection. So now I've got this ONET occupation that is found in a certain OPM series, and that OPM series is found in a NASA class code, which is in a NASA group, which is in a particular skills mix group. That's part of the developing the model, and that's adding to my knowledge graph as I go forth. Started off with one piece of knowledge, the ONET. I added the NASA component class codes to that as another piece of my knowledge graph as I'm starting to build my ontology and taxonomy across this knowledge graph. Well, that gets me part of the way there. Now I have my employee. So I've got an employee and they've got information, but it's not broken down as easy as the ONET was already structured. What I have for my employee, I've got information such as their position description, their resume, their training history, their evaluation, things like that. They're primarily written prose that I need to extract, and that's where we'll utilize the natural language processing to help us a little bit in that. And I'll go over that in a little bit. Along with that, another piece that I can add to that from a knowledge graph perspective, now that I've got the employee into that graph model, I can now add things such as what center are they located at? What organization in the center do they work at? What part of a current ongoing transitional program we have going on called MAP that do they fall in order to be able to map that employee across the skill set or the workforce across the agency? As well as that, I can add financial information. Who do they charge to? You know, what project is that involved in? What program, theme, and mission up the line, which will later on allow me to identify what elements or skill sets do I have in a particular project, a particular program, or even a particular center. That way I can start identifying things when managers ask me what skills are located in my programs or projects. But one of the questions that recently came up is what skills am I losing due to attrition within my program, my projects, or my themes? So those are questions that we're trying to identify utilizing this knowledge graph to be able to identify those things. So that kind of builds your graph model. It gives you an idea of how you might want to build a graph model, and you can start adding things to it. you see down in the bottom middle corner or possible other sources, which we're still working on, is things such as training. I can take the training information from an employee, and this training, if it's situated correctly or definitely documented correctly, it's going to have a syllabus, and that syllabus will hopefully have the objectives the employee is going to learn, the skills they may gain, the knowledge they may gain. All of that is a wealth of information to help tie back to the employee what they may be learning, and maybe even getting information from some of their social media profiles will allow us to gain more information of how their skills are either increasing across the employee's career life or career path, so that we can try to see where they're going and what direction they may be going as far as they grow within the company. So there's still a lot of things we need to look at of how we're trying to get that information in, but the basis there that it's very easy to plug in new information with these relationships that makes it easy to make that knowledge graph grow very easily, as opposed to a relational database where you've already got a kind of a set schema. I can add and remove relationships in this a lot faster, a lot easier without doing harm to the rest of the knowledge graph. So now I've got the graph model situated. What am I going to do with it? Here's kind of my KSATT knowledge graph workflow as I move through things in picture format, and then I'll kind of go a little bit of how we did this. Again, on the left-hand side, you have these occupations. And those occupations all are broken down into various elements. Again, the KSATTs, the knowledge, the skills, the abilities, the tasks. All of those are broken down. You take that information out of that. You take the description of the knowledge, the skills, the abilities, and so forth, and you feed that into a Doc2Vec model as the vocabulary to train a model that you then use to infer the same knowledge, skills, abilities, and tasks from an employee. So on the employee side, I've taken those job descriptions, those performance evaluations, and so forth, and I've used the text within that to infer against the model to figure out what skills may they have similar that you can find in that information within the employee, and then add that as a relationship back into a Neo4j database, graph database. So as I add all that information both from the occupation side and the employee side, now I've developed a database that has occupations related to skills, employees related to skills. Now I can start applying some different graph data science libraries in order to extract the information out. That'll hopefully allow me to help identify skills gap, maybe look at their career path, some succession planning, or even strategic alignment models as we try to identify where we should be aligning our skills based on our programs or projects necessary to fulfill our new missions. So a lot of that is going on in the back end as far as the data science components of it. But let me dive in a little bit into how I did that and show you a little bit of visualizations of what that looks like when we pull it out. So one of the first things that we did, and I want to thank here really my current intern, Madison Gibson, and I'll have her information at the end. You can reach out to her if you would like. But she developed a script for me that allows me, a Python script, that pops up this little bitty dialog box there that connects you to your database, puts in your database password, automatically connects to the import folder within that database, and it can do a fresh install of the ONET database itself. So this script will actually connect to the ONET website, download the current CSV files, and then use that and put that into the import folder and use that within the queries in order for me to be able to, the queries to run in order to create the database itself. All of this takes about, I'm trying to remember last time we did it, it's a little over 5 minutes, which is quite fast considering how it took me doing it by hand. It took me almost half a day or a little bit longer to do it all by hand, running each script individually. Doing it like this, where the Python script runs it all together, makes it a lot faster, creates your database, and puts in the information about the employees as well. Here's the caveat I have to give you here. All this information is on the GitHub repo. However, you're going to have to comment out the information about the employees and how to create that in order to run this script. Because while I can share you the ONET database information, so that's open data, I cannot share the employee data that we have. So you'll have to comment out that part of the script in order for this script to run, and just upload or create your own ONET database. that you can start playing with and try to figure out how you might want to apply this to some of your employees or some of your workforce. Once you've got that done, you've got this database, and you've got these very simple, here are all the different elements that you can extract out of this knowledge graph. Again, we've already spoken a little bit about these different types of information that's in there from, excuse me, from workforce characteristics, requirements, occupational requirements, all of that's embedded into the graph database and kind of related to each other based on the OwnNet taxonomy that they've already had and created there. So once you have that, now you can start working across that and do things such as maybe compare work roles. So in this particular case, this is a visualization from a previous version of the database. But let's say here in the center, you have a data scientist, and that data scientist has certain competencies, certain knowledge, and essential knowledge they may have. But if I'm, maybe in my organization, I'm trying to develop data scientists, I don't have enough data scientists. Well, I can see that a software analyst shares a good number of the knowledge that a data scientist, as far as the elements associated to that work role. So while it may not be a complete data scientist, I could upskill this individual to become a data scientist if they so chose, by providing them knowledge on certain things such as data quality assessment, business intelligence, data mining, and so forth, in order to get them to that role. And you can take that scenario in many different ways. Maybe I'm a software analyst and I want to become a data scientist. I can try to figure out what else do I need to learn in order to become a data scientist. So those are some of the things you can do about comparing work roles across that, which has really helped our organization take a look at our employees, especially as we're going through a transitional in our skill sets to try to identify how we're going to realign our skills in order to meet our missions to get back to the moon and onto Mars. So another example of something you can do within this type of a knowledge graph is you can rank skills by occupation. If I want to identify those most important skills within an occupation, and OwnNet did this quite well within the information you get from the OwnNet data source, they evaluated each skill within that particular domain or industry and asked industry experts to give it a data value of importance for that skill, from a range from 1 to 5. So in this case, if you look at this query that I wrote here, I'm going to pull out certain OPM series occupations, a 2210, a 1550, and so forth, and utilizing both of those, I'm going to match the basic skills for that occupation that have a data value higher than 3.75. And that's again on a scale from 1 to 5, and I'm going to order it in descending value there. And the result says for this 1550s, anyway, a computer and information research scientist, the most important basic skill, it's just understanding written sentences and paragraphs in work and related documents. It shows just from a basic level, that's what individuals are looking for within that type of occupation. And you can pull this information out for various types of elements. Again, basic skills, cross-functional skills, tasks, knowledge, and so forth. And then combine that together to maybe get your ideal requirements for a position or for an employee that you want to look at. So another thing you can do once you develop this knowledge graph is maybe you want to find out, how do I make a career change? I'm an employee, I'm a management analyst, and I'm tired of that, and I want to look more into an IT-related workforce, and I want to do more IT-related work. Within this particular knowledge graph, I created here a cipher projection where I am just returning, again, all occupations within a particular workforce. So 2210s, which are information technologies, 0880s, and 0340s, which are in the management analyst type of workforce. I pull them out, and I want to compare those. And again, I'm pulling out the importance data value of 3 or better, and bringing that out. And now once I've taken out that projection, I run a similarity algorithm against that. In this case, just basically a Jacquard similarity across those 2 nodes. And then I pull out and I return this table showing me that a management analyst is actually almost 57% similar to an online merchant, 46% similar to a search marketing strategist. But if I wanted to become a business intelligence analyst, if I wanted to move more to that, I'm about 46% of the way there based on just my knowledge, the knowledge comparison across that. So it's a starting point for me to identify what knowledge do I need to learn in order to become a business intelligence analyst, or how, as a manager, find more business intelligence analysts across my workforce if I'm trying to develop that workforce and gain that. So I know what I need to do in order to provide training, to provide resources in order to increase those types. So it's a lot of different questions you can answer with one very simple similarity stream here. One of the last things I want to show here, as far as from a cipher perspective, this was done by Madison recently. We did a projection here, and we're looking for employees that are similar to an occupation based on employees. So here I'm trying to find employees that are almost alike based on their abilities. And I took the last names out here to protect the innocent. But again, the first thing you do is you create a cipher projection to just work on that projection, and then do a similarity again, try to figure out based on the number of similar nodes or abilities they have, how close they are, and again, ranked by similarity here, showing that Bradford and Constance are pretty close together. Actually, Constance and Craig are almost identical in these routes. Again, gets you the ability to answer questions that you're trying to find about your employees based on the information you have. And the more information you get, the better these results will be as you start adding more and more information from other resources or the data sources about the employee or about the occupation. So one of the things we presently are looking at is how do we do this and how do we show this to individuals from an application perspective. Working with Madison, we've looked at developing a simple Dash app here that I'm going to show a quick video. As I run this video, you basically connect to your database. It pulls up a drop-down box. You put in whatever you're looking for. So you can see it's going to auto-populate. And here, if I'm looking for computer and information research scientists, I show other occupations that have similar skills and the number of the ratings as far as the similarity percentage across that. It's a work in progress, but again, it was very simple to complete, to connect to the database and be able to pull out that information live and very quickly to get your analysis done, and allowing an employee and or a manager to start looking for information about work roles or job opportunities. One of the things we're looking at doing here is having an internal talent marketplace where managers can submit programs or projects that they want to have employees bid on, basically saying, here's the project that I have, here are the skill sets that I'm looking for. They can do one or two things. The manager can look for employees and match those skill sets and reach out to them directly and say, would you be interested? Or I, as an employee, say, these are the skill sets that I have or I want to focus on. Are there projects out there that meet those skill sets? And I can find those occupations or work or projects that are there for me that I can look at. And this is what we're trying to do with this type of an application. So as we add to the knowledge graph, we talked a little bit about how we started adding knowledge graphs here. We've got the occupation, and on that occupation, then I added the employee or using the OPM series to that occupation. Then I added the employee. Finally, I added information about that employee and who they're charging to. This simple Bloom visualization shows that in here you have a particular cost center in blue there with individuals that charge to that cost center. And that cost center then is charging to a project. That project goes to a program. That program goes to a theme, and that theme eventually goes to a mission. What you can answer from this is just mind-boggling in the sense that now I can identify not only what skills an employee has that may be charging to a particular cost center, I can then aggregate that all the way up to the mission and show management, here's where, one, your skill sets are clumped. Maybe they want to think about moving skill sets around, or two, what skills are they losing? I can also show the employees that have attrited over the last year and see, based on the employees you've lost, this is the skills you've lost, compare how they looked to the previous years, and then they can start making plans on how they might want to backfill or which skills they want to backfill first based on the importance of those skill sets. And here's, again, very similar Bloom visualization, but looking at one employee here and where they've charged to, but then taking it to the other side, taking it to the right side. Here's the knowledge, or actually cross-functional skills within that employee and the occupation that employee has. So you can start identifying not only particular cross-functional skills or other elements that may be important to this occupation, but maybe other occupations this employee may have. So you can now start identifying these skill sets and elements across not only the employee, but back towards the occupation, as well as to the other side of how you're charging that. And you can eventually aggregate how much money you're spending, if you wanted to, per various skill sets, and see where you're outlaying most of your cash flow on that. So that's kind of how we can develop a knowledge graph, starting from one simple base, an occupation data set, add other information you may have from other data sources, from your OPM series in our case, to our employee, to our cost information. Eventually, we're going to add training information, maybe some social media information about the employee, and start generating more and more information. Future things you can think about as far as maybe adding certifications and licenses and maybe academics and where they're tied there. What universities they've gone to, so you can identify the universities that are providing you the most employees, or maybe areas you want to look at, or what gaps you have. A lot of things you can start expanding on as you start finding the information. The only thing you have to figure out is how are they related to the current information to add to that knowledge graph. I think it's an exciting time. It's an exciting field that we're really working in as far as people analytics. I think knowledge graphs, and in this case, graph databases, provide a great opportunity to really expand on how we utilize that information that we currently have in people analytics and provide much better answers to our managers and to our employees of things that they want to look for within our workforce. So based on that, more to come. We're still working on a recommendation engine. I have certain skills, what jobs are available that I mentioned before, even an expert finder. I'm looking for certain individuals with a particular skill set. You can imagine it, Nat, that we've got some groups that have, one or two skills that we need world-class skills, and maybe only one or two people have that. We want to be able to find those individuals a lot faster. We can also do this, develop training plans. If I know that these are the skill sets I want to attain, what training do I need to provide in order to get those skill sets, both from a manager's perspective, what do I need to offer to my employees, but also from an employee perspective, what do I need to learn if I want to get that next position or get that promotion or go higher than that. And we can also outline career paths. In the past, this is what an employee learned or what the employee job roles were over time. This is one path you can take. Other individuals may have taken a different path. We can track that within the knowledge graph and be able to show that over time and see how they progress, giving the employees an option of how they want to move back and forth, and what areas they want to learn, or what tangential areas may be available to them. Again, providing a wealth of information not only to the employees, but to the managers and how we organize our skills across the workforce. So hopefully I stuck the landing. Here's my contact information, as well as my intern, Madison Gibson. We've been working on this for the last several months. We hope to have more updated information. Again, you can find on my GitHub repo the data for actually installing the ONNET part of the database, but also it will have some information in there of how we structured, or how I structured the employee information to be able to create those relationships. Keep an eye out on that GitHub repository. I'll be adding more as I can, especially some of these Stash apps that we're creating in order to help visualize some of these databases. At this point, I'm open to questions. Okay. One question I got here, and I usually get this a lot also, so great question, is how do I promote these types of use cases to management? How do I get management to buy in utilizing graph databases or knowledge graphs within my organization? And it's a question that I get quite often from many organizations or many individuals. What I have found, at least what's worked for me, is that I start off with an issue or a problem that's kind of contained as far as the organization that you may, it's not widespread. It's something that you can work with and have the appropriate data to utilize it, but it's also high visibility. Something that if you are able to really support and answer that question, have a little bit of a wow factor. And I usually do this when I started doing this many years ago, probably 8-9 years ago now, I would do it just like that, and then I would write an article or some kind of blog or some kind of presentation on that. And we have an internal morning email that goes out to all the employees that I would put that presentation in there, and without a doubt, within the first 30 minutes after that email would go out, I would get at least 5 or 10 calls. Can you help me do what you just did? I'm having the same problems. Can you show me how you did that? And that would start getting buy-in and allowing me to be able to utilize that advocacy from those individuals to be able to promote what we're doing better there. So another question here. Okay, let's see. Why can't I just use a traditional relational database for a knowledge graph? You know, and that's a very good question. In a sense, you know, I've already got a traditional relational database. Why do I need to go to a graph database? Can I do it there? Sure, I'm pretty sure you could if you tried hard enough. And I've done SQL development in the past. I was a SQL developer 20 plus years ago, early on in my days, and I'm sure we could. There's ways of doing it. What I found is the fact that you've got this schema that you have to create and develop to be beforehand in order for you to be able to actually start working development. You get all that information there, you do your normalization, you get your foreign keys associated to it with your primary keys, you start developing, you create that database and you input data. Lo and behold, 2 months later, you got some additional data that you want, or just a separate piece of information you want to add to it. How is that going to impact your schema that you currently have within your current database? Do you need to redo it? And many times when you have to do that, it's just a big headache. What I found in the graph database, since it's schema-less and you're basically just developing the data model, creating those relationships are very quick to develop that. If I find new sets of information that I can somehow relate back, whether it's 1, 2, or 3 hops down the road, it's very easy to create the queries to connect those resources together. And if I don't like it, I can easily pull it apart. But it makes the creation of the database faster. And of course, you know, you've always talked about the actual querying of the information. As you get more and more information into these databases, and you have more joins in a traditional SQL as opposed to a graph database, the graph databases will be faster returning the results than you would have in a traditional relational database. All right, I appreciate the opportunity to speak to you guys. I hope some of this information was helpful. I really appreciate the opportunity that Neo4j has given me to kind of share this information. And I look forward, if you have any questions or want to reach out to me, feel free to connect, and always love to meet people in the knowledge graph communities. Thank you.